Hello everyone, welcome back to your online learning channel. How are you all? Hope everything is going well. So we are on a bit of online learning process during this pandemic condition all over the world, and the reason I'm here to help you out on this topic, ratio and proportion, in this video. Now this topic is from chapter number 7 of ICSE syllabus. This is though not based on typically one board. Ratio and proportion you can find it in all the other boards like CBSE and all the state boards. So any student may get help out of this video. I hope so. Okay, so let's start the topic. In class 10 we are basically focusing on the properties of ratio and proportion, the basic understanding of ratio and proportion. You have already learned, I think, in previous classes, 7 or 8 maybe. Anyway, we are going to discuss a bit of that in this class, and then we'll start with the properties. Okay. So what is a ratio? So a ratio is a comparison, this is important, a comparison of the sizes of two or more quantities, quantities of the same kind by division. If we have two quantities A and B of the same kind in same units, so then the fraction A by B is called the ratio. So you're basically comparing two quantities. That's very simple. It is written as A is to B. Now this is the format we write A is to B. The ratio of A is to B is also given by A by B or A colon B. Okay. So now when we have three quantities of the same kind in same units, and then they are in ratio A is to B is to C, if the quantities are all are AK, BK and CK respectively, where K is any non-zero real number. Okay, let us try to understand ratio. Suppose I have here two objects. Everyone knows this, a Rubik's cube, all the sides are equal. Now I have another object and it is cylindrical in nature. Now when we compare these two objects, we have to compare same unit. We cannot compare the weight of this cylindrical object with the length of this cube. If we have to compare, we have to compare their weight together. Or if we want to compare the measurements, like I want to compare the length of this cube, then I have to compare with the length of this cylindrical or height of the cylindrical object. So we cannot compare the weight with the length. So that is what it means, we have to take the same unit. So weight to weight we are comparing, and then if we want to compare the measurements, we can compare the measurements. Now here we have three models. So we have this red model, say A, and we have another model, this one is B, and we have a third model, C. Let us first compare A and B. So what we are going to compare is, we are going to compare their height. So we can say when we are comparing, we can say that A is 2 times as tall as B. We are comparing, right, 2 times. So we don't have to write any unit because a ratio is free of units. We are comparing same kind, so we don't have any unit. So A is 2 times as tall as B. Now we can also say, when we compare C and A, we can also say A and C are of the ratio 1:1 because they are same. Okay, so A is to B, we can write it as, so A is 2 times of B, so A is 2 and B is 1. And if we write A is to C, that's 1:1. Similarly, we can also compare C is to B. When we measure their height, we see that B is half of C, or C is 2 times that of B. So if I write B is to C, so I have to write B's part first, so that is 1:2. So what we did is we compared those models according to their height. Okay, and we cannot compare weight of one model with the height of one model. We can just compare their height, or we can compare their weight also if we compare weight of each and every model here. Okay, so let's move on to the next part. Now here we are going to read about composition of ratios. So there are few different types we need to understand. When two or more ratios are multiplied together, then they are said to be compounded. Okay, when you multiply those two ratios, what you get is a compounded ratio. Okay, so if you have A by B and C by D, two ratios, then A into C, we have to multiply the numerators. Okay, so if you have A by B and C by D, so two ratios, so what is the compounded ratio? It is, we multiply the numerators in the numerator part and we multiply the denominators in the denominator part. So AC by BD is another ratio, and this ratio is known as compounded ratio for those given ratios. Okay, I hope that's clear. A ratio compounded with itself is known as a duplicate ratio. Okay, and similarly we have triplicate ratio. So in duplicate ratio we have, when we multiply A by B and A by B, so we multiply the numerator 2 times, we get A square, and the denominator 2 times, we get B square. So this is the duplicate ratio. If we multiply one more A by B with this duplicate ratio, we get a triplicate ratio. So that's we're multiplying A 3 times A cube and B 3 times, that's B cube. Okay, so that's very simple. The next one is sub-duplicate ratio, and we have sub-triplicate ratio. So when we have duplicate ratio as A square by B square, the sub-duplicate ratio is root over A is to root over B, and the sub-triplicate ratio is cube root of A is to cube root of B. And finally this reciprocal ratio of A is to B, what we do is we take B is to A, we just take the reciprocal of the ratio. Okay, so that is called the reciprocal ratio, B by A. That's all for now in this composition part. We have exercise 7.1 here. This is question number 1. An alloy consists of 27.5 kg of copper. Okay, alloy, I think everyone knows, it comprises of 2 or more metals mixed in a particular ratio. Okay, so we say it is an alloy, and this alloy consists of copper and tin. Okay, so the copper part is 2 3 by 4, sorry, the copper part is 27.5 kg and the tin part is 2 3 by 4 kg. Okay, you have to find the ratio by weight of tin to the alloy. That means we are going to find the ratio of weight of tin and not this weight of copper, we have to take the weight of the alloy. Okay, the copper weight is 27.5 kg, so 55 by 2 kg, and the tin weight is 11 by 4 kg. 2 3 by 4, it's 11 by 4 kg. So we get the total weight of the alloy. If we add copper and tin weight, we get the weight of the weight of the alloy. We get 121 by 4 kg. And now the ratio between tin and alloy. So we take this is the weight of tin, and this is the weight of copper. Alloy. So 121 by 4 is the alloy weight, and 11 by 4, this is the tin weight. Okay, so the ratio of tin weight is to copper weight is this, and when simplified we get 11 is to 121, and that's 1 is to 11. So moving on to the next question. Okay, this is question number 2. We have so many sub questions here. We are going to choose one of the questions, that is 3. Okay, so if we have here, you can see a minus b by a plus b. This is a ratio. Okay, we have another ratio, a plus b whole square is to a square plus b square. And we have a third ratio, a power 4 minus b power 4 is to a square minus b power 4 whole square. So we have 3 ratios. Okay, find the compounded ratio. So we have to find the compounded ratio, and what you mean by compounded ratio, we have to multiply the numerators and the denominators to form the ratio. Okay, so the compounded ratio of those 3 ratios, we're going to multiply the 3 ratios. So a plus b whole square, we have written it 2 times, and a power 4 minus b power 4 is when we write a square power square minus b square power square, so a square minus b square. So basically we are subtracting one square from the other, so you get a square plus b square into a square minus b square, and that a square minus b square is again factorized into, simplified into a plus b into a minus b. So what we have done is we have just found the factors of all those terms. So a square plus b square has no other factor, but a square minus b square, we can find the factors a plus b into a minus b, and whole square, that means we have 2 times both the terms. So that's when you multiply, simplify each and everything. So basically we can cancel, you see a plus b whole square 2 times we have, so it goes 2 times. Then we have a plus b here, and again a plus b here, so it gets cancelled, and a minus b, and we have a minus b another, yes, a minus b whole square 2 times, so this is gone, and we have a square plus b square here, and a square plus, all the terms gets cancelled, and the ratio is 1 is to 1. Okay, moving on to the next question. We have question number 3. Find the duplicate ratio. That's very simple. Duplicate ratio is actually taking square of the numerator and the denominator. So we have chosen the second one. Duplicate ratio of root 5 is to root 7. So we took square of root 5 and square of 7. So that's 5 is to 49. Similarly, the next one is triplicate ratio. We have chosen third one. That's triplicate ratio of 1 cube is to 2 cube. Now be careful, it is already given 1 cube is to 2 cube, but we have to find the triplicate ratio of that, so we have to take cube of that. Okay, so even though the cube is given, you have to be careful about that. You have to take cube of the given terms, so you will have 1 is to 8 cube, that's 1 is to 512. Okay, see the next one. You have to find the sub-duplicate ratio. That means you are going to find the square root of the terms. So square root of 1 by 4 is 1 by 2, and square root of 1 by 9 is 1 by 3. So 1 by 2 is to 1 by 3, and when simplifying we get 3 is to 2. Okay, moving to the next question. This is question number 6. Find the sub-triplicate ratio. So as we found triplicate ratio to be cube, so sub-triplicate ratio is taking the cube root. We took the third one. Okay, so we have to take the cube root of both the numerator and the denominator. So if you take cube root or power 1 by 3, it means the same. So 3 gets cancelled. You have 3a is to 4b. Okay, going to the next question. Find the reciprocal. This is the simplest one, you know that. You are just going to reverse the denominator and the numerator. Okay, so 3 square is to 4 square. The reciprocal ratio of that is 4 square is to 3 square, and then 16 is to 9. Okay, now question number 9. We have 2 questions here. Out of that we'll take the second one. Now here we have x is to y given, that is 2 is to 3. Okay, this is the first ratio, x is to y. And then we have y is to z, another ratio, 4 is to 7. Okay, now when you have this kind of questions, okay, we have 2 different ratios, and we have to find the ratio of all the quantities at a time. Okay, so in that case what you need to do is you have to find the common term. Now you can see that in those 2 ratios we get y here and y here. So if we can make that equal, okay, this is the basic thing you should understand. If we can keep y in both the ratios same, we can compare all the 3 terms. Okay, so that's what we are going to do. So we have taken the LCM of y's term in both the ratios. So here we have 3, and in the second one we have 4. So the ratio is 12. Sorry, common or LCM is 12. So x by y, we need to convert y to be 12. Okay, so what we are going to do is we're going to multiply this with 4. Okay, so x by y becomes 8 by 12. So the first ratio is 8 by 12, and similarly if we do for the second ratio, we get y by z to be 12 by 21. Now we see that y in both the ratios is 12, so that we can compare the 3 terms, and we get x is to y is to z as 8 is to 12 is to 21. I think that's very clear. Okay, so that's simple too. Let us see another question based on this. This is question number 10. Again we have 2 questions, but we'll take the second one. Okay, in the previous question we had the ratio. In this question we have the equations. From the equations we're going to get the ratios, and once we get the ratios we're going to compare the common term. So b, we see that it is already equal, so we don't have to take LCM and make them equal again. We can just compare them. So it's very simple. We can see a is to b is to c is 4 is to 3 is to 2. Okay, that's what we have, the comparison of a is to b is to c. Let us see one more question from this exercise in this part of the video. Okay, now if you see the question, now when we write it, we open the bracket. If we multiply y with this term 3x minus y, we get 3xy minus y square, and if we multiply x with this 4x plus y, we get 4x square plus xy. So that is 5 is to 12. Now this is the given part, this is given. Okay, and you have to find the value of x square plus y square is to x plus y whole square. Now in such questions we are just going to use identities like a plus b whole square here, x plus y whole square. So first we're going to cross multiply this one, 5 with 4x square plus xy, we get 20x square plus 5xy, and 12 with 3xy minus y square, we get 36xy minus 12 square. Okay, so rearranging the terms, we get this, and we have to find the ratio of x's to y so that we can put it in the required condition. Now this is a form of quadratic equation. This is x by y whole square, this is x by y, and there is no x by y. So this is a quadratic equation, and when we split the middle term, and we get the zero product rule, where we have these two terms equals to 0. So each one of them, when the first one we take, we get x by y equals to 3, and x by y equals to 3 by 4. Okay, and if we take the second term as equal to 0, we get x by y equals to 4 by 5. Now this is not the end of this question, because we have just found x by y and we have two values. Because this is a quadratic equation, we have two values. We have to put those values to find the required ratio. Okay, so when we take the first value of x by y, that is 3 by 4, and we need to find the value of this. Okay, we have to put x by y. So in the numerator and denominator, we have divided both the terms by y square, you can see. So what we get when we substitute the value of x by y, that is 3 by 4, in the given condition, we get the given relation or the given ratio equals to 25:49. Similarly, when we take the second value, x by y equals to 4 by 5, and we use the same way, we find x square plus y square is to x plus y whole square equals to 41 by 81, or 41:81. So I hope you all understood, and the questions basically are based on this type only. These are very simple, and that's all for now in this video. If you have understood and if it helped you, don't forget to hit that subscribe button. See you in the next class.